All right, so let's look at an 8th grade test. So as you can see, there's not as much to do in 8th grade, but it's that real capstone of what they've been doing in 6th and 7th. So in the next couple of years, you may have to go back to some of those 6th and 7th grade standards and revisit them and talk about, the mechanics of them so that then they can use it for the analysis in 8th grade. So here's an example from Illustrated Mathematics. Remember, as I've said in the past, that is your best source for a sample task because they are being, evaluated and managed by the folks who wrote the standards. And so this idea that, okay, here's this data table that we have already collected the data on. Here's a scatter plot, rather. And here's a bivariate data. So what does that mean? That means I'm mapping the relationship between the text that students send and their GPA. So those are the two variables. That makes that bivariate data because for each student, I've collected 2 data points. I have collected, how many texts they send. They sent the day before, I guess this is one day. And then their GPA, their most recent GPA. So the question is, is there a relationship between the number of text messages sent and the GPA? And so you could have to talk about the overall pattern. They could talk about any, deviations in terms of are there some kids who seem to send a lot of text but they have a very high GPA, or there's some kids who seem to send no text but they have a very low GPA. And so they could start to, lay a line of best fit in here and make a judgment as far as what their, what their thoughts are in terms of the association here. So there's a whole lot that kids could do, and if we take those 8th grade standards we just talked about and kind of bring them all to bear, the students could formulate a very comprehensive response to this scenario. So as you can see, this 8th grade stuff really lends itself to a whole lot of student-focused activities too. All right, so then here's another task. So that last task was very open-ended. So this one gets a little more specific and a little more procedural, and it might be hard to see, but this is a scatter diagram, and it is bivariate data because for each bird, they are graphing the length of the bird, the length of the egg, versus the width of the egg. So we're trying to think about, how the length and the width of birds' eggs are related. And so you'll see they have already computed the average for you in this prompt number 1. And so then students are asked to mark that on the diagram. So they'll put the X on the diagram, and it'll help them see where the mean falls relative to, for each of those variables, relative to the rest of the data. And so then they're asked to, to use the graph to decide what is the relationship between the width and the length of birds' eggs. A great piece of bivariate data along these that kind of has a similar relationship is you have the students write their first initial with their dominant hand for 30 seconds, then you have them write their first initial with their non-dominant hand, and you graph that. And then you can talk about what does the line y equals x mean, and if you fall on that, maybe you're ambidextrous because you can write your letter the same amount regardless of what hand you use, but then kids will start to talk about, well, that's because, they may have a really easy letter for their first initial, like L or something like that. So there's a whole lot of data you can graph and go through this same process that's in this task, where you have them mark an average on the diagram, talk about the relationship, talk about another sample that has a different average for one component, and then they have to extrapolate what probably is the average for the other component, and talk about ratios here too. So, and then relate that ratio to the slope. So, I think there's a whole powerfulness to this task in terms of helping kind of mesh that conceptual understanding of data with that procedural understanding of finding averages and looking for, you know, plotting points, and then also certainly looking at ratios in the context of slope. So a whole lot of coherence going on here. Okay. Then we go. Then the next task, then I also did not include the text of the task, but I included the graph because I thought it was telling. And so here's some more bivariate data. And again, here we're graphing the relationship between the population of a state and the number of airports it has. And they have already put in the model for you. Now, what's interesting to note is the notation on the model. And that's one of the biggest reasons I chose this task. You see up there in the top right-hand corner, it's hard for me to point in the PowerPoint, but you can see there, y equals 1.35 e negative 06x plus 6.1016. And so that helps you see that they're going to be using kind of calculator notation for scientific notation in some of these tasks. And if you open up this task, I also attached this task to the message that went out for this recording, or I mean for this presentation. If you look at the rest of the task, you'll see there's lots of questions that use this notation. And so getting your students fluent with understanding what those symbols mean, what does that E mean, you know, and that is times 10 to the negative 6. So what does that mean? Is an important precursor to having students be successful with this task. And that brings up an important point that, you know, there's going to be grade level notation and, you know, kind of things that come into play here. And so, you know, in the middle school, we developed this idea about exponents and negative exponents. And so it's important then for students to be successful with this task if they have a sense of what that means. And then that's actually a very, very small number. And it's not a negative number either. There are some kids that will see E negative 06 and think that that means it's a negative number also. So, and if they understand that that's a coefficient of x in a linear equation and that means it's a slope, then they'll know from this graph that it's not negative, because clearly the line that has been drawn in is a positive slope. And so you'll see kind of, you know, how the data clusters, and then in the task you'll see several questions being asked about the data. So I leave that for you to kind of take a read through. But it also gives you an example then of kind of how these questions are going to be asked. Where it might be where the kids are given the graph, they're given the equation, and then they have to draw lots of conclusions with that information. And maybe even add in some more data and tell what it might do to the model. So there we go. I wanted to just finish up today by looking at a couple of different pieces. And I mean this, I say this top one tongue-in-cheek, but I'm very serious that if we do these standards and we don't use real data, not just data that's given to us like the puppy task, if we don't use real data, we might as well go home. I mean, because I feel like if there's no other time that we bring in mathematics from the real world, it has to be now. Show the first two websites. The third one is the census website, and many of you may use that already. Gobs and gobs of data that you can get from the census. And again, if we think about what the students are being asked to do with the multiple populations, drawing inferences, wow, I can get data from one state and data from my home state, and, you know, make some conclusions about comparing the two states. That's exactly where we're going with this statistics piece in middle school. So those two pieces, that census website is amazing, and there's all kinds of data you can pull. And maybe if we have time at the end, we'll look at it. But I wanted to show you the other two. Okay. See if I can get this. All right, so let me come out of the screen sharing and then go back and show you the flowing data from another application. So just a moment.